In this video, we're going to look at solving rational equations. One of the things you guys want to remember is that we've actually solved rational equations before. And to recap some of the steps that we use for solving rational equations, the first thing we want to do is factor all of our denominators if possible and state our restrictions. Once we've factored our denominator and stated our restrictions, it's also easier for us to identify what our LCD is. We will use this LCD to clear the fractions. We do so by multiplying both sides of the equation by the LCD. Then we solve that new equation, and we're always going to check our solutions. We'll see an example today where checking our solutions is not only suggested, but absolutely necessary. Our first example is a similar example to what we've seen in previous videos. X minus 3 divided by 4 equals 5 divided by 14 minus x plus 5 over 7. The first thing we want to do, again, factor our denominators. Since all of our denominators are monomials, we don't have anything to do for that. Then we want to state restrictions. Since all of our denominators are numbers, they're constants, we have no variable restrictions. Then we want to identify what our LCD is. In this case, the LCD between 4, 14, and 7 is 28. So what we're going to do is we are going to multiply both sides of our equation by 28. On the right-hand side, we see since we've got two terms that we're going to have to distribute this. And in the next step, I'm actually going to show that distribution. So I have 28 times x minus 3 over 4 equals 28 times 5 over 14 minus 28 times x plus 5 over 7. Now this step might seem unnecessary to some of you, and if you're really good at distributing and simplifying at the same time, you can omit this step. But I encourage you guys, if you're having struggle or having issues with simplifying and distributing at the same time, that you take this intermediate step. What we can do now is go through and simplify each of our fractions individually. 28 over 4 is 7. 28 over 14 is 2. 28 divided by 7 is 4. So what do we have left? We've got 7 multiplied by x minus 3 equals 2 times 5, which is 10, minus 4 times x plus 5. This is a baby equation we're all very comfortable solving, so let's go ahead and take a second to do that. First, we're going to distribute 7x minus 21 equals 10 minus 4x minus 20. Combining like terms on the left and the right-hand side of the equal sign, we're going to get all of our x's together by adding 4x to both sides. 11x minus 21 equals negative 10. Add 21 to both sides. 11x equals 11. And if we divide both sides by 11, we get x equals 1. Now to check our solution, we simply plug it back into the original and make sure that the left and the right side are equal. 5 over 2x equals 17 over 18 minus 1 over 3x. Again, since all of our denominators are monomials, there's no factoring that needs to be done. But since we do have variables in our denominator, we need to state restrictions. Our restrictions from both of our variable denominators is going to be 0, so x could not equal 0. And then we're going to identify the LCD. Look at the numbers or the coefficients first, the 2, the 18, and the 3. The LCD with those is 18, and since we have an x in two of our denominators, we have an x in our LCD. Now we're going to multiply both sides of our equation by our LCD, 18x. Again, here I'm showing you that step of distributing the LCD to every single term. It makes it easier when you're simplifying each of your fractions. 18x divided by 2x is 9. 18x divided by 18 is just x, so the 18's go away. 18x divided by 3x is 6. So what do we have left? 9 times 5 is 45 equals x times 17, or 17x, minus 6 times 1 is 6. Add 6 to both sides. 51 equals 17x. Divide both sides by 17. X equals 3. Now, in this particular example, we want to start illustrating the checking of our solutions. We got a solution of x equals 3. What we want to do is make sure that our solution doesn't contradict what our restrictions were. So I had originally a restriction that x cannot equal 0. Since that is not the solution I got, my solution is okay. X over x minus 2 equals 2 over x minus 2 minus 2 over 3. There's no factoring that needs to be done. We can state our restrictions. Our restrictions, x cannot equal 2, and we see that in this first denominator and the second denominator. And then our LCD is going to be 3 times x minus 2. We're going to multiply both sides of the equation by 3 times x minus 2. And you want to make sure when you multiply through by the LCD that you leave it in factored form. Again, there's that intermediate step that's going to allow me to see how each of our terms is going to simplify a little bit easier. 3 times x minus 2 divided by x minus 2, the x minus 2's will cancel out. 3 times x minus 2 over x minus 2, again, the x minus 2's cancel out. 3 times x minus 2 over 3, our 3's cancel out in our last fraction. So what do we have left over? We have no more denominators. We have 3 times x in the first term equals 3 times 2 is 6 minus x minus 2 times 2. So I'm going to put the coefficient out front so that I can distribute. 3x equals 6 minus 2x plus 4. We're going to add 2x to both sides to combine our variable terms. 5x equals 6 plus 4. On the right-hand side is 10. Divide both sides by 5, we get x equals 2. Again, in this problem, because we had restrictions, we need to make sure that we check our solution against our restrictions. If you look, our solution of x equals 2 is the same as our restriction that x cannot equal 2. This makes us very sad. In this case, we have no solution. Now, this example, x equals 2, is what we call an extraneous solution. Let's write that down. And extraneous solutions come about in several types of equations. Rational equations is one of them. So anytime you've got restrictions, you want to make sure that the answer that you get doesn't contradict those restrictions. In some cases, you'll get one solution, and that will be the same thing as one of your restrictions, so there's no solutions. In other cases, you'll get more than one solution. If the resulting equation here ended up being a quadratic, where we would get more than one solution, then maybe one of them would work, maybe one of them wouldn't work. So you need to make sure that you check both of your answers or all of your answers against your restrictions for any extraneous solutions. Shifting gears, now we're going to look at how we can use rational equations in problem solving. In the city of Orlando, 1 out of 50 homes pulls water from a well. If there are approximately 125,000 homes in Orlando in total, how many of them are using wells? This is a proportion problem. Many of us have solved proportions in other classes, so this should be very comfortable for us. Our first ratio is 1 over 50, and it should be proportional to the total number of homes that use wells. So the total number of homes that use a well is X, and the total number of homes in Orlando is the 125,000. In the case of a proportion where you've got two fractions that are equal to one another, we can solve this using cross multiplication. 50 times X equals 125,000, or 125,000 times 1. Divide both sides by 50. X is equal to, I think, 2,500. You can check that with your calculator. Some things to remember when you're solving or setting up proportions. The numerator of my first ratio had to do with the number of homes that had a well over the total number of homes. So the second ratio I set up has to have the same order. The numerator is going to represent the number of homes with wells specifically, where the denominator is going to represent our total. Only in the case where you've got a proportion, in other words, two fractions that are equal to one another, can you use the cross multiplication. If you look at some of the previous examples, let's look at this previous example. We cannot use cross multiplication here because I don't have one fraction equal to another fraction. If you wanted to use cross multiplication, you would first have to combine these two fractions as one, and then you could use cross multiplication. And that's another technique for solving rational equations besides clearing the fractions like we saw in our 3 examples previously. Greg can paint a room. That's what that should say, paint. A room alone. Not the greatest typing job today. Greg can paint a room alone in 6 hours, and his brother Pat can paint the same room in 5 hours alone. This is a Siri autocorrect, I think. How long will it take them to paint the room together? This is what we call a work problem. And most of these problems can all be set up the same way. So with a work problem, we're going to organize the information that was given first using a table. So we've got information about Greg, Pat, and them working together. Now we know how long it takes Greg to finish the room, and then we're going to talk about his rate. So if Greg can paint the entire room in 6 hours, what's his rate? Well, he completes the entire room in 6 hours. When we talk about rate, we usually want to know a unit rate, which is how much of the room is he painting in 1 hour. Again, think about it. If it takes him 6 hours to complete the entire thing, then he's only completing 1/6 of it in each individual hour. So his rate would be 1 over 6. Pat paints the room in 5 hours, so Pat's rate is going to be 1 over 5. Now we don't know how long it takes them to paint the room together. That's what we're solving for, so that will be our variable x. But if it takes them x hours together to paint the room, then that means their rate together is x. Now we can use this information and the simple thought that the rate of them working together should be the sum of their individual rates. So we set up a rational equation, 1 over 6 plus 1 over 5 equals 1 over x. Again, this is their rate alone. Their sum of their rates alone should equal their rate together. And this looks just like one of those first examples we saw. We'll state our restrictions, x cannot equal 0. And this is a pretty obvious restriction. Thinking about what x represents, it represents time. It's not going to take them 0 hours to paint this room together. That's not possible. Our LCD is going to be 30x. And we're going to go through and multiply both sides of our equation by that LCD. Now that we've distributed our LCD, we can simplify each of our fractions. 30x divided by 6 is 5x. 30x divided by 5 is 6x. And 30x divided by x is 30. So what do we have left? 5x plus 6x equals 30. Combining like terms, we get 11x equals 30. And if I divide both sides by 11, we get x equals 30 over 11, which is approximately 2.7 hours. In this example, since we're dealing with a variable for time, it is meaningful or more meaningful to have our answer written as a decimal. Pay attention to the directions though on how they want that decimal rounded. Some variations of your work problem might include giving you the amount of time it takes Greg to paint the room alone, the amount of time it takes them together, and then solving for how long does it take Pat to paint the room by himself. So using this table, you can organize that information, understanding that if you take the individuals and you add them or add their rates, that should equal their rate together. There was something else I wanted to talk about with the work problems, but I can't remember. Maybe I'll think about it before the end of the video and come back to it. Our last example is our favorite example. We know this from our SATs and probably at least some standardized tests we've seen. A plane is flying from Orlando to LA, a distance of approximately 2,500 miles. On the trip there, the plane was flying 750 miles against the wind, and it took 25% longer than the return trip flying the same speed with the wind. How fast was the wind blowing? So take a second, maybe pause the video and reread this problem. We want to make sure that we understand what's going on. So try to visualize in your head, we've got a plane and it's traveling from Orlando all the way to LA. Now, on the trip out to LA, it's flying against the wind. What does that mean? What does that tell us? Well, that means when we set our plane at cruise control, there's a force acting against it, which means it's going to actually go slower than that 750 miles that we set the speed at for the plane. On the return trip, which is the same distance, now the plane is flying with the wind. So again, if you think about setting your cruise control, now you've got a force coming from behind the plane, actually causing it to move faster. You experience this also if you're in a boat and you're on a river, let's say, going upstream or downstream. So these problems are distance, rate, time problems. And just like we saw in the previous example, we're going to use a table to help organize the information that we have so that we can easily set up an equation to solve. So we're going to set up a table for the return trip, or excuse me, the trip out and the trip back. And for both trips, we're going to talk about the distance, the rate, and the time. Now, the distance we know is fixed for both of them is 2,500 miles. Now, the rate we don't know. And here we might stop and say, what are we actually trying to find? What should our unknown be? Since we want to know how fast the wind was blowing, let's let x equal the speed of the wind. For the rate on our way to LA, we know that we set the speed at 750, but since we're flying against the wind, we're actually going to go slower. And we're going to go slower by the factor that represents the speed of the wind. So the rate to LA is going to be 750 minus the speed of the wind because it's acting against us. So our trip from LA back to Orlando, since we're flying with the wind, we're going to take that original speed of 750 and we're going to add to it the speed of the wind. Now to figure out our time column, we're actually going to use that relationship that distance is equal to rate times time. If distance equals rate times time, what does time equal? To solve for t, we divide both sides by r. So time is equal to our distance divided by our rate. And we have our distance and our rate for both trips. So the time is going to equal 2,500 divided by 750 minus x for the trip to LA. From the trip on the way back is going to be 2,500 divided by 750 plus x. Now that we've completed our table, we need to figure out what information have we not used in the problem and how does that help us set up an equation. The information that we haven't used yet is this part. It took 25% longer than the return trip. So the trip out was 25% longer than the trip back. I'm actually going to write that down. The trip out there, so the trip to LA, is the same as equals 25% more. And I changed the word to more because I think that will help us see how we're going to translate this in the next step. 25% more than the trip home. And let me emphasize, the time to LA is 25% more than the time from LA. So the time to LA and the time from LA, we have those expressions here in our table. This is what we don't have, the 25% more than. How do we figure out what's 25% more? Now, we can do this using a simple exercise of thinking about shopping. If I decide to sell something at 25% more than what I paid for it, how do I determine what I'm actually going to sell it for? Well, to do that, you actually multiply by a factor of 1.25. The 1 is the original 100%. The 0.25 represents that increase of 25%. The time from LA was 2,500 divided by 750 plus x. And this equals the time on our way to LA, which was 2,500 divided by 750 minus x. Now, getting to this point is the most challenging part of this problem. Now we just have a rational equation. We can use our steps that we've seen in previous examples. So maybe stop here, take a break, look at the question again, make sure you understand how we got through our steps, and you may even need to rewind to the beginning of the problem to rehear that explanation. I'm going to clear this now, rewrite that equation so that we can solve it. So we had 2,500 divided by 750 minus x equals 1.25 times 2,500 divided by 750 plus x. What I'm going to do first is multiply. This 1.25 is a fraction. It's over 1. So I'm going to multiply it by that second fraction. We get 2,500 divided by 750 minus x equals 3,125 divided by 750 plus x. 1.25 times 2,500 is that 3,125. Now we've got two fractions equal to one another, so this is sort of like a proportion, and we can cross multiply. Now that we've set up our cross multiplication, we're going to distribute on both sides. We get some pretty large numbers here, but that's okay. So we get 1,875,000 plus 2,500x equals 2,343,750 minus 3,125x. Now we're just combining like terms on the left and the right hand side of the equal sign, starting with our variable terms. Subtracting this 1,875,000. Hopefully you guys are using a calculator to make these arithmetic or simplify these arithmetic problems. And when we divide both sides by that 5,625, we should get x is approximately equal to 83.3. And thinking about our units, what does x represent? From our previous slide and in the beginning of your work, x represents the speed of the wind. So the speed of the wind we're going to measure in miles per hour. Which means that the altitude that the plane was traveling, the wind was actually a speed of 83.3 miles per hour. I don't know if that's realistic or not, but that's the answer that we got. And I know it's correct. Just to summarize what we saw today, guys, when we're solving rational equations, we want to factor the denominators and make sure we state restrictions. Stating restrictions, I've emphasized how important that is, but now we have seen that if you don't state restrictions, there's a possibility that you have an extraneous solution and you don't know it. So we want to make sure that we state our restrictions. We multiply both sides of the equation by the LCD, and that will clear our fractions. If we don't want to use the LCD to clear our fractions, we can combine the fractions on one side of the equal sign so that we have one fraction equal to another fraction, and then we can cross multiply. Either way, you get the same answer, it's just a different process. And then when we get to the end, we want to make sure that you always check your solutions against your restrictions. In the event that you have an extraneous solution, you would eliminate that solution from your set. If that's your only answer, then your equation has no solutions. If one of them is extraneous and the other one is not, you would just leave the one answer that is not extraneous. We looked at a couple word problems. The three main types of problems that you guys will see are your proportions, your work problem, which is that paint example, and the distance, rate, time problem like the plane example. We'll see you guys next time. Thank you.